Good morning, students. In previous session, we discussed about various forms of straight lines and conversion of general equation into various forms of straight line and problems related to that. Now we are going to discuss the point of intersection of two straight lines which are lying in the same plane and concurrent lines and angle between two straight lines, some other key concepts. If two lines are a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0, let this is L1 and L2 are intersecting at px comma y. Let these two straight lines L1 is equal to a1x plus b1y plus c1 is equal to 0 and L2x plus L2 is equal to a2x plus b2y plus c2 is equal to 0 are intersecting at the point px1 y1 like this. This is L1 is equal to 0 and this is L2 is equal to 0. Then point of intersection is p x comma y. Our point is we have to find the coordinates of p, that is x coordinate and y coordinate of p. What is the point of intersection? Is there any problem? We can solve these two equations by eliminating method or substitution method or arrow cross method, or now we have to find the formula for finding point of intersection. Here, by taking the coefficients a1, a2, b1, b2, c1, c2, again a1, a2, b1. By taking arrow cross method, put this is x coefficient, y coefficient and constants. Let me remove this. That implies x by b1 c2 minus b2 c1 is equal to y by c1 a2 minus c2 a1 is equal to 1 by a1 b2 minus a2 b2. This method is called arrow cross method. This is arrow cross method. By using this method, we are going to find the point of intersection of two given straight lines. Now, that is by taking x as subject, x by b1 c2 minus b2 c1 is equal to, from taking these two, 1 by a1 b2 minus a2, and by taking these two, y by c1 a2 minus c2 a1 is equal to 1 by a1 b2 minus a2 b2. By bringing this denominator to the right side part, it will multiply. That implies x is equal to b1 c2 minus b2 c1 by a1 b2 minus a2 b2. Similarly, and y is equal to, from bringing this part to right side, c1 a2 minus c2 a1 by a1 b2 minus a2 b2. So, point of intersection p x comma y is equal to b1 c2 minus b2 c1 by a1 b2 minus a2 b2. This is x coordinate and y coordinate is c1 a2 minus c2 a1 by a1 b2 minus a2 b2. Okay, by utilizing this formula, we can find the point of intersection directly by substituting the values of a1, b1, c1 and a2, b2, c2. Okay, this is the first one. or by we are well known about eliminating method. By eliminating x or y in given first two equations, first equation and second equation, by equating the coefficients of x we can eliminate, or by equating y coefficients we can eliminate y, and then we can solve x value and y value, which is very easy to you can follow, or directly by using this formula you can find. Okay. Next, here next point is a straight line is there and 2 points are there. If A and B are 2 points, A x1 y1 and B x2 y2 are 2 points in the same plane, while line segment joining AB is there. If a straight line L is equal to AX plus dy plus C is equal to 0, divides the line segment AB joining A comma B in the ratio minus L11 is to L22. It is a theorem. Let's suppose the intersecting point of L and AB is P. Then let AP is to PB is equal to L is to M. L is to M. The point of intersection by section formula we can find the coordinates of P. Therefore, P is equal to Px comma y is equal to Lx2 plus Mx1 by L plus M comma Ly2 plus My1 by L plus. Since P belongs to L is equal to 0, that implies it should satisfy the given equation. That implies A into, instead of x we can write Lx2 plus Mx1 by L plus M, Ax plus dy. B into y means Ly2 plus My1 by L plus M plus C is equal to 0. By multiplying with L plus M, that implies A into Lx2 plus Mx1 plus B into Ly2 plus My1 plus C into L plus M is equal to 0. By simplification, by taking L as common, so replace or write another term Alx2, or taking L as common, A into x2 plus B into L is there plus by2 plus C. The remaining terms plus A m by taking M as common, M into Ax1 plus by1 plus C is equal to 0. That implies L into Ax2 plus by2 plus C is equal to minus of M into, by bringing this term to right side, Ax1 plus by1 plus C is equal to C. We have to know the ratio L is to M. So that implies by bringing this to right side, L by M is equal to, if we bring that side, minus of Ax1 plus by1 plus C by ax2 plus by2 plus c. That implies that is nothing but minus of L11 by L22. L11 means instead of x we have put x1, instead of y we can put y. Similarly L22, x2 by substitute the values x2 and y2 instead of x and y, then L22 will be given. That implies L is to M is equal to minus of L11 is to L22. This is our conclusion. That means if a straight line ax plus by plus c divides the line segment AB in the ratio LSTM, that is LSTM is nothing but minus L11 is to L22. Here we have to discuss some two points. If this is one way and equivalent will be there, A, B, L will be there, L is here. External point, if L intersect AB externally, it is also possible. Here L intersect AB internally. That means A and B are lie on both sides, each side of a straight line. But here A comma B lying on the same side of the straight line. When and where these two are possible, we have to know. If we have a minus L11 by L22 is greater than 0, that means positive. When it is possible, L11 and L22 have same symbol, then we can say that A comma B lies on the same side, each side of the straight line. Or L11 and L22 have the same sign, that means same for plus or minus, then we can say that A, B are lie on the same side. Okay, we have to know that also. I will write one point here. If L11 and L22 have same sign, that means positive or negative, that implies and implied by A comma B lie on this on each side, on both sides, separate side. L11 that means R, then L11 by minus L11 by L22 greater than 0, that implies A comma B are lie on each side, both sides. L11 and L22 have opposite sides, opposite signs, that implies and implied by A comma B lie on the same side of the line, of the straight line. That means if L11 and L22 have same sign, opposite sign, then minus L11 by L22 get negative side symbol. So then we can say that it intersect externally. Okay. These 2 points also you have to remember. Next point. Now we can find the point of intersection. The second one is we can find the straight line. If the straight line divides the line segment AB, is the points lie on the same side or on both sides, we can say that by taking L11 and L22 we can find by finding L11 value and L22 value. If L11 and L22 have same side, then A comma B lie on each side, both sides, either side, or L11 and L22 are opposite side, then AB are lying on the same side of the straight line. Okay, next point. Concurrent lines. What do you mean by concurrent lines? Here also we discuss one thing. X-axis divides if x-axis this x dash x y dash y y dash x dash. Suppose here AB is a straight line. X-axis divides the AB line segment in the ratio minus y1 is to y2. Similarly, y-axis is divided AB in the ratio minus x1 is to x2. You have to remember that also. Now we are going to further point, that is concurrent lines. What do you mean by concurrent lines? What do you mean by concurrent? Point of concurrency. Concurrent lines. If two lines intersecting at a point, then we call that point, that lines are intersecting lines, and the point is known as point of intersection. Similarly, if three or more lines passing through a point, then those lines are said to be concurrent lines, and the point is known as point of concurrency. If here some other point is there, family of straight lines. If some straight lines having same properties, then we say that those lines are a family of straight lines. Okay. By connecting these to concurrent lines, we can say that if two straight lines are parallel or if straight lines are perpendicular, then if here we have to know a point that if L1 is equal to 0 and L2 is equal to 0 are parallel, then lambda 1 L1 plus lambda 2 L2 is a pair of straight lines with two pair of straight lines. Similarly, if L1 is equal to 0 and L2 is equal to 0 are perpendicular, then straight. At this point, if L1 is a straight line and L2 may be another straight line, these two are parallel, then L1 lambda 1 L1 plus lambda 2 L2 is a straight line which is parallel to these two straight lines. This is nothing but lambda 1 L1 plus lambda 2 is also a straight line which is parallel to it is a straight line L1 parallel, this is L3, L1 parallel L3 and L2 parallel L3. The equation are like that. Okay, it is the meaning of that point. There is no need to discuss another thing. If L1 is equal to 0, there is another point. L1 is equal to 0 and L2 is equal to 0 are two intersecting lines or intersecting lines, then the equation of any straight line passing through that line may be in the form L1 plus lambda L2 is equal to 0 or L2 plus mu L1 is equal to 0, where lambda is not equal to 0 and mu is not equal to 0 for some lambda comma mu belongs to constants. If two lines are given that intersecting lines, the point of intersection may be P, then any straight line which is passing through the P should be in the form of L1 plus lambda L2 is equal to 0, or L2 plus mu L1 is equal to 0, or L1 plus KL1 is equal to 0, KL2 is equal to 0, like that. This is called the family of straight lines, because these lines are passing through only one point, intersecting point, that is, we call that concurrent point. Now we will go to discuss another point, that is concurrency of lines, concurrency of point of concurrency, concurrent line. If three or more lines passing through a single point, then this is point of concurrency, point of concurrency. If two straight lines intersecting, then we call this as intersecting point, point of intersecting, point of intersect. That is the difference between these two. If two lines only there, then we call that point is point of intersection. If three or more lines passing through a single point, then we call that point is point of concurrency or concurrent point. We call that lines as concurrent lines. This is intersecting lines. Now we will go to concurrent lines. If a1x plus b1y plus c1 is equal to 0, a2x plus b2y plus c2 is equal to 0. Next, a3x plus b3y plus c3 is equal to 0. All three lines lying in the same plane, and these three are passing through. Let this is L1, L2, L3, and these three are passing through a point. This is L1 is equal to 0, this is L2 is equal to 0, and this is 0. L3 is equal to 0. The point of congruency is P. Then the point of congruency. Is there any condition? There is a condition to find that. There is a proof. By solving these two, you can find the point of intersection. If these three lines are concurrent, the point should be lie on the L3. By substituting the point of intersection of first two lines should be put in the third line, should satisfy the third equation. If satisfies the third equation, these three are concurrent lines. If not, these three are not concurrent lines. For that, we can find easily, that is, there is a condition that by taking A1, B1, determinant of A1, B1, C1, A2, B2, C2, A3, B3, C3, the determinant of the quotient matrix should be to 0. Then sigma A1 into B2 C3 minus B3 C2. Sigma is nothing but the expansion of this statement A1 into B2 C3 minus B3 C2 plus B minus B1 into A2 C3 minus A3 C2. That implies L1, L2, L3 are concurrent. Or that implies L1, L2, L3 are concurrent. If three lines are given, show that our question is, show the given three lines are concurrent, or find the value of unknown thing k if three lines are concurrent. For that problems we can use this formula. this condition. Condition for concurrency is that the determinant of your coefficients matrix it should be equal to 0 or sigma A1 into B2C3 minus B3C2 is equal must be equal to 0. This is about point of concurrency. Now we go to further point. The angle between two straight lines. Angle between two straight lines. If two lines are congruent and the intersecting lines, L1 is equal to 0. This is L2 is equal to 0. This is theta. Let the angle between acute angle is theta. Then we can find the angle by using cos. Cos theta is equal to mod of A1 A2 plus B1 B2 by root of A1 square plus B1 square A2 square plus B2 square. By using that formula, we can find the value of theta. If the cos theta is equal to k, some value k, that implies theta may be found by using cos inverse k. Okay. If we know the general, if the given straight lines are in general equation, or if these two equations in the slope metric form, or we know the slopes. If the slopes of equations are m1 and m1 comma m2 and the angle is theta, then we can find the angle theta by using tan. By using the formula tan theta is equal to mod of m1 minus m2 by root of m plus m1 m. By using this formula, if this is equal to some k, if tan theta is equal to some k, that implies theta is equal to tan inverse k. By using these two cases, two formulas, we can find the angle between two straight lines in various cases. If the given equations in general equation, you have to use cos formula. If the slopes are known, you have to use tangent formula, tan formula. Okay. By using this, we can solve the so many problems which are given in our textbook. Okay. Next problem. Here there is another point, that is perpendicular distance from a point to the given straight line. We have to know, that is, if there is a point P x1 y1, there is a straight line ax plus by plus c is equal to 0. Then the perpendicular distance, that is Pm, this is d, let's see, can be found by using the formula perpendicular distance of Px1 y1 to the straight line ax plus by plus c is equal to 0 is Pm is equal to perpendicular distance d is equal to mod of ax1 plus by1 plus c by root of a square plus b. By using this formula, we can find the distance between a straight line and a point. We can find the distance. Similarly, there are two straight parallel lines. Suppose this parallel lines should have the same slopes. So, parallel lines are in the form of ax plus by plus c1 is equal to 0 and ax plus by plus c2 is equal to 0. They differ in only constants. Now we have to find the perpendicular distance between these two straight lines. Distance between parallel lines ax plus by plus c is equal to 0. Ax plus by plus c1 is equal to 0 and ax plus by plus c2 is equal to 0 is b is equal to mod of c1 minus c2 by root of a square plus b. By using this formula, we can find the distance between any two parallel lines. These are the some points we discussed. First point is the point of intersection, concurrent points, concurrent lines, properties of concurrent lines. Next, perpendicular distance from a point to the straight line, perpendicular distance between two straight lines we are discussed. From these you have to solve so many problems in the problem. Next video we can solve some problems. Goodbye.